Mare volcanism. And those are areas where the Apollo astronauts were really focused on because they're easy landing sites. You're going to have a lot of that high titanium composition, a lot pyroclastics more similar to these black and orange glass beads. But if you were to go somewhere else, more in like say a highlands region, there's potential for a different type of volcanism to have occurred, a more silicate rich magma, and that would be very, very different. It's kind of up for debate about what we would expect that composition to look like right now. It's a very hot topic, no pun intended. But yeah, it would definitely vary depending on where the lava tube was.
Question number 4. How big were these volcanoes and are they still active?
That is a great question. They are not still active. And I think in terms of relative size, these vents are small compared to what we're used to seeing on Earth on the scale of like hundreds of meters versus miles, you know? So I think they were relatively small and definitely not still active. Although we do sometimes pick up like tremors or moonquakes, and that can cause off-gassing of trapped volatiles from previous volcanic activity. So while they're not active, you can still see the remnants and effects of that.
Awesome. All right, next question. If the pyroclastics describe different temperature at different regions, were there more areas ravaged with lava and magma than others? And what causes this?
This is a great question, and I don't know if I can answer all of it, and I'm sorry. So yeah, different parts of the moon experienced different areas of volcanic activity, and you can actually really see that. I'm going to go back to my first slide. You can see that that's what was happening with the Mare. You've got areas where the crust is thin that the magma can well up from, and that's where you end up with the Mare pools. And that's going to be that high titanium activity. What was the other part of the question again?
What causes this?
Okay, what causes this? So this is basically lunar tectonics, and the short answer is I don't know, and I'm not sure if anyone really knows.
To research.
But, yeah, my best guess would be lunar tectonics at the time, potential effects from gravity from the Earth-Moon system, pulling and pushing on the core of the moon. There's several different reasons, but it's an area of active research.
Awesome. Next question. How far back in time was volcanic activity happening on the moon, and how long did it last?
That is another one that is really up for debate and a very good question. So the easy answer is we know that the Mare activity happened about 3 billion years ago. And we know that from the pyroclastic beads that I talked about today, and also the basalts that we have returned. So there's some other evidence of a different type of volcanism called non-Mare volcanism that potentially happened a little later, around 1.5 to 1 billion years ago. But the evidence for that is a little more difficult to find. We see that it could have been happening in not just these Mare regions, these dark areas, but potentially in more highlands dominated regions. And that it's a difficult question to answer because, we're still getting new evidence every day, and more studies are being done. So if you have an interest in these things, there is grant money to be found for sure.
All right, are there any more questions, folks? Well, personal question from me. Since you like volcanic areas and stuff, have you been to Craters of the Moon National Park?
I have not.
I highly recommend it as soon as the COVID restrictions have lifted. It is a huge area filled with lava flows.
Oh, that's great. That's going on the bucket list.
And I'm told wear good shoes if you decide to go hiking off the beaten path. Because because there's a lot of pahoehoe kind of lava flows and they rip shoes, I've been told.
Oh, I would believe that, definitely.
Do have another question. What causes the striations that look like, what causes the striations that are on the South Pole?
Which striations on the South Pole are they? Let's see. I think what they're talking about are these like bright areas here. Those are crater rays. And that's just from impact cratering that's been happening.
That's what I was, that's why I was confused on. I was like, wait, striations, huh?
Yeah. I mean, now there are, so that there are small, I guess, fissures and faults along the South Pole too, and that's just caused by tectonic activity. And in fact, you can look up. There's a Grail Voyager gravity map that can show you the crustal thickness of the moon and may explain some of those faults and striations.
All right, any other questions? Getting a bunch of compliments on the chat that your topic is very intriguing and it was super interesting, and thank you. Oh, and we got one more question. Hang tight. So somebody's asking, Artemis is going to be exploring this in the future. What can you tell us more about that?
So Artemis is a new lunar program that's been launched. It's the follow-up to the Apollo missions. And basically what they're going to do is they're going to try to go back to the moon and do some more sampling with the intention of having that be our stepping stone to get to Mars. So I don't know a whole lot about the Artemis program. It's still being deployed right now, but we do know that they are actively looking to further the research on the moon, and that, you know, when we do these decadal surveys as a planetary science group, the you know, studying the moon and understanding the surface processes of it to include this volcanism topic is high on the priority list.
All right. Are there any more questions, folks? All right, if there are no more questions, thank you so much, Elizabeth, for your amazing talk.
All right, thank you, Michelle. This has been so much fun.
All right, so next up, what we're going to have is some amazing experts from Astronomy on Tap who specialize in a wide variety of different fields. So they're going to discuss with you today as something a bit of a special treat. They're going to discuss like some of the unique things that you've been seeing in the news and basically getting to talk with them as experts of why is this so cool? So we have up presented by Adam Barg, Tracy Becker, Vincent Hugh, Lizeth Magana, Christine Ray, and Sam Tobach. So they're going to basically do a quick survey of what's cool in the news and why you should check it out. So ladies and gentlemen, from Astronomy on Tap, the floor is yours.
All right. Hello, everybody. Hopefully you can see the screen here. We're going to be doing kind of rapid fire, cool things going on in the news. And I'm going to be talking about light pollution. Many of you, if you've been coming to Astronomy on Tap, know that I'm not a professional astronomer. I'm just somebody who really loves space and protecting space from Earth. So light pollution impacts more than just astronomers. We are coming up on the migration season for thousands of species of birds. 1 out of every 3 migrating birds in the US passes through Texas every spring. So that is a lot of birds passing through a very large state that has some really big cities. So one of the things that we do to help protect wildlife, but also, of course, to protect those night skies, which are beneficial for both humans and animals alike, we ask people to turn off their lights during the peak of migration season. Of course, migration season has already started. If you are somebody who enjoys giving to the wildlife around us, since we are in their home just as much as they are in our homes, we want to encourage both our neighbors and nearby businesses to turn off their lights, especially April 19th through May 7th from 11 p.m. to 6 a.m. Of course, you can turn them off longer. You can turn them off all year. That's what I do. It's a really great way to help protect these awesome birds, like the beautiful painted bunting that you see here on the screen, as well as tons of different species of hummingbirds, flycatchers, warblers, lots of different critters. There's also an app called eBird from the Cornell Lab of Ornithology, where you can track and see how many of these different species come by, how many of them you observe. It's a really fun way to do some citizen science. And of course, all of this protection for the night skies for these birds helps us be able to see the night sky during the night in our cities. So I will pass it on to the next person.
Hey everyone. So thanks. Oh, do we want to do questions? I guess we'll do all the questions at the end. Hi, and I'm going to talk a little bit very quickly about my favorite topic, which is asteroids. And we actually, Sam was just talking about protecting the sky from the Earth, but good news, we're also protecting the Earth from the sky. And recent observations of the most recent close flyby of the asteroid Apophis has showed that we are safe for the next 100 years. So this is an asteroid that kind of caused a lot of excitement a few years ago when it was first detected, because we didn't know its trajectory very, very well. And there was a small chance that it would actually impact the Earth in 2029. And so we can see that in 2029, that it does come very close. That's 19,000 miles. That's what you're seeing in this video here, showing just how close it gets. All those little blue dots are actually, I believe those are supposed to represent some of the satellites around the Earth. So it gets pretty close to our satellites. It gets only 7% the distance from the Earth to the moon. So it gets pretty close. But we've already known for a while now, follow-up observations back then in the early part of the 2000s made us certain that we didn't have to be worried in 2029. The most recent flyby that just happened in 2021 helped us rule out any possibility of a collision in 2066. And then there's also 2068 is another close flyby twice. And so now we know that at least for the next 100 years, we don't have to worry about Apophis. And you can see the radar images at the top. Those are the images of the asteroid. And when we took those images, we were able to also do basically a ranging experiment where we could verify exactly what its trajectory is still looking like. And so we're good to go for a while. So that's the news in asteroid news today. So we'll pass that on to the next person.
Hello, hope you're all enjoying Astronomy on Tap so far. Hope you all indulge a little particle physics. Exciting new, not a discovery quite yet from the LHCb project at CERN on the Large Hadron Collider. They study these decays from a specific kind of subatomic particle to another, and during this decay, it also emits these pairs of leptons. So it's either an electron and an anti-electron, or a muon and an anti-muon. And the standard model of particle physics says that these should be generated in roughly equal probability, whether it's electrons or muons. But exciting news is that it looks like electrons are favored so far. Obviously, they're not quite sure enough yet to say this is definitely happening, but it's looking promising. And what this means is it's probably the first step on the path to kind of answering some big questions in cosmology, like what is dark matter and why is there normal matter about in the universe when we think, based on the standard model, that there should be equal quantities of matter and antimatter that would then annihilate, and basically no universe, just lots of photons flying around doing nothing. So yeah, keep an eye out for that, because hopefully they'll be announcing a discovery sometime in the future. That's me done. So next subject.
Hello guys, thanks Adam, thanks Sam and Tracy, and thank you for the organization again. Yeah, so some news from the planets. Actually last week, there were some pretty cool results, very neat science with Jupiter that were published. So Jupiter is a fast rotating planet, and we've been able to measure the winds of Jupiter just by looking at tracking the velocity of the clouds that you see here. So all you see here are clouds that are located in the troposphere of Jupiter, which is the kind of the lower part of the atmosphere. And above that, it's been very challenging to measure the wind. So you can see here on this plot that the black curve shows you the velocity, the total wind speed of those clouds that we've been tracking over the years for decades now, and it's been consistently dominated by eastward or westward propagating winds that are mostly very important in the equator and kind of dies down when you go towards the poles. So really at the equator, you see this very strong jet towards the east and then west at slightly higher latitude. But so there has been a lot of questions about how high those winds can go in the stratosphere, and it's been challenging to answer that because we don't have any clouds in the stratosphere. But thanks to ALMA, which I'm going to explain on the next slide, please. ALMA is actually an incredible tool that it's a collaboration between the US, Japan, Europe, and the Republic of Chile, which is actually a assemblage of a telescope, which is called an interferometer, which are all located on this very high altitude plateau, about 15,000 in American units. It's 15,000 feet altitude, yes. And it's about 66 antennas that are each about 12 meters in diameter. So it's by itself, one antenna is really very big already, but it's a set of many antennas that are observing the same source with a slightly different perspective, which when all combined together allows you to give you an incredible spatial resolution. And since they're observing not actually a visible light, they're observing radio emission, in this wavelength range, you are able to have an incredible spectral resolution. You have an incredible resolution on the measurements too, not only spatial, but also you can decompose the light to an incredible precision. And thanks to that light, we are able to measure molecules in the stratosphere that are flowing along the planet. And the biggest discovery was the measurements are shown here along the limb, because this is only there that you can measure those winds. The biggest results was to show that near the equator, you see a signature of those strong east-west wind that you see in the troposphere from the clouds. But the biggest results was really around the poles, as you can see here in the South Pole, where we actually see aurora. And so we saw actually a vortex that circling the pole. We think it's circling both pole, but we could only see the South Pole on those observations, as you can see here. And they're kind of co-located with the aurora. So if you can play the video on the last slide. This animation was made by the European Southern Observatory that shows the extent of this giant stratospheric jets that were discovered in the South Pole. So very, very pretty cool results. First time we can actually measure stratospheric wind on Jupiter. So it's an open door to many more discovery about Jupiter meteorology. You're on mute, I think, Christian.
Whoops. Okay. Hi, everybody. I hope you can hear me now. So I'm going to be talking a little bit about Ingenuity, which is going to be the first ever rotorcraft or helicopter flight on another planet. So Ingenuity was actually part of the Perseverance rover. So it was like a separate little robot that hitchhiked a ride onto Perseverance, which landed on Mars back in February. It's only 4 pounds, so it's a really, really tiny little guy compared to the big rover. So Ingenuity is just a technology demonstration. So it has a camera on it, but it doesn't have any scientific instruments. It's not meant to do any science. It is just there to demonstrate that, yes, we can or cannot fly a helicopter on Mars. And if it succeeds, that's probably going to pave the way for lots of other future Mars copter and maybe other outer planet copter missions in the future. Because you can do a lot more science when you can fly around to different places and not have to worry about like getting stuck in holes and things like that. Next slide. So as I mentioned, Ingenuity hitched a ride on the Perseverance rover. So Perseverance first had to drive it from the place where it landed onto the airfield or helipad. And from there, it has to be unfolded. So they like origamied the heck out of this thing just to get it to fit on the rover in the first place. So the unfolding process has actually been kind of complicated and it lasted several days, but this picture over here on the right is what it looked like as of yesterday. So it's almost there, it just has to drop onto the ground. Next slide. So once it's on the ground, it's on its own, it's disconnected from the rover, and it's going to perform a series of test flights over 30 Martian days, starting in the next few days in early April. So for its first flight, it's going to fly off the ground about 10 feet up, 3 meters. It's going to hover there for like 20 to 30 seconds, and then it's going to come back down. And then they're hoping that if that's successful, they can start to fly it longer and higher up and just see as much how high and how long they can get it to go up there over 30 Martian days. The tricky part is that this is brand new technology. Mars is really cold. You know, we've overcome this with rovers and things before, but never with helicopters. So it's going to have to keep itself warm using solar power. It's also going to have to be able to communicate back and forth to the International Space Station. So all of that, we're just kind of fingers crossed that the tech works and that it survives 30 Martian days. And if so, it's going to be a really exciting technological, you know what I mean, feat that we've overcome for the first time. Yeah, and that is it.
All right. So thank you guys ever so much for your amazing presentations. I know it's been really exciting to see some different news in astronomy pop up and to been learning about them. So folks, are there any questions that you want to ask these amazing experts? Question number 1, how does Texas compare to other states when it comes to light pollution? I think this is directed to you, Sam.
That is a really great question. So there are tons of different maps that you can look at online that will show you the light pollution across the United States and across the globe as a whole. Really, the biggest impact on light pollution is large cities and large industries. So we're seeing, for example, in West Texas, where the increase in oil production, those facilities produce immense amounts of light pollution. And there are ways that they can combat that, but those ways are more expensive than the cheap way that just sends light out into the universe. And so it really depends on where you're looking at what you're looking at. Texas is the home to multiple International Dark Sky Association parks, as well as one international dark sky preserve, which is really awesome. We are also a state that has a few, I think we have 2 or 3 dark sky communities. And these are places like Limberley, Texas, where the community as a whole has decided and agreed to protect the night sky by implementing ordinances that require both businesses and individuals as in the city as a whole to protect the night sky. Places like Flagstaff, Arizona are some of the first places that really took that to heart and really pushed for dark sky protection. So if that's something that you're interested in and you want to learn more, the International Dark Sky Association, the IDA, is a really wonderful resource. You can find tons of resources for what you can do in your own home, in your own community, and ways that you can reach out to legislators and say, hey, this is something that's important to us. We want to make sure that the sky is protected.
Sorry, I muted myself by accident. So next question for you, Sam. What effect does light pollution have on migrating birds?
That's another great question. So many different species, not just birds, but animals like bats, moths, sea turtles, tons and tons of different animals rely on the night sky for direction. There is a lot of research that shows that they are able to tell which direction they're going based on what is in the night sky, which is always really fascinating to me. We're not the only ones looking up, right? We're not the only ones paying attention. And so when we have these huge skyscrapers and these large amounts of light pollution, it's really confusing. If you're a bird that is relying on, for example, the Milky Way to determine where you're going, and you fly by San Antonio, Texas, that has the Tower of the Americas lit up at night, that's going to throw you off. We see a massive increase in bird collisions with buildings with increased light pollution. So every time you hear about, for example, large amounts of birds that are running into buildings, there's a very high chance that that was due to light pollution.
Okay, these next 2 questions are for Tracy. Of all the doomsday theories out there, how concerned are you about another asteroid?
Oh, right now, not at all, because we haven't spotted any that have given us any concern. So I think we're in good shape right now. There's always the chance, though, and that's sort of why the Planetary Defense Coordination Office and NASA and other agencies are always kind of keeping their eyes to the skies. So making sure we have the facilities to be able to find and then track the asteroids, I think, is really key. But so, I mean, the odds are not, super high that it's going to happen any day now. But these things do happen on, millions of years timescales where you kind of get one of these big ones, and it has been 65 million years since the last one. So, maybe that's give or take another 10 million years. So we could be in great shape. So I think it's important to keep looking. And I think we do have the advantage now that if we found something, we could do something about it. And there's a really cool mission coming up with NASA called DART. And that mission is actually going to be a tech demo as well to see what happens if we did put an impactor into a small asteroid. How much could we nudge that asteroid out of the way so that it wouldn't impact the Earth? So we do have options, and we are working on safety protocols to protect the Earth.
All right. And of course, the next question is how do we know that there won't be a collision with Apophis and sometime in the distant future? Because how do we know if these trajectories are not affected?
Yeah, so that's a great question, because they are. And this particular asteroid is so interesting because its trajectory kind of keeps it kind of close to the Earth's orbit all the time. And so what we can do is we can, using things like radar especially, we can get a very, very, very accurate measurement of exactly where it is and exactly what its velocity is. And so we can map out its trajectory, but usually it is only for something like the next 100 years. It's hard to go beyond that because there are other effects. So as these asteroids, come into have encounters with planets or maybe even another asteroid, that gravitational pull can nudge it. The biggest factor, and that's being accounted for in these calculations, which I think is incredible, is called the Yarkovsky effect, which this is actually changes in the orbit of the asteroid due to how it gets heated by the sun, and it re-radiates that heat. So you can imagine if you had just like, it's kind of, there's different things like a sail almost, or different ways you can imagine where like the sun actually heats it up, and then because it's spinning and it's moving, depending on how it re-radiates that heat, that can actually cause it to nudge the asteroid in its orbit a little bit as well. So we actually have a pretty good understanding of the Yarkovsky effect now. And so we can actually include that in the calculations when trying to figure out where it's going to go. But you can only do that for so long. But I did look up the odds for this one, at least for Apophis, for 100 years from now. And in 2016, our measurements using radar and other techniques showed it was like 1 in 150,000 odds, which put us at 99.99933%. And these most recent observations in March of this year made it even better statistics than that. So we're even better than 99.9999933. So we're good for the next 100 years.
Beautiful. Next question that's coming up, and I think it's possibly for Vincent. Why do the winds on Jupiter depend upon latitude, and why do they travel in different directions? And is this just unique with Jupiter, or is it all the gas giants?
That's a very good question that we still at this point don't perfectly understand. Yes, and this is something we see on all gas giants. They have east and westward propagating jets. So that's that's still something we're trying to understand. It's just a giant ball of gas that rotates very fast, and one of the consequences of that is that you have jet stream at very fast velocity that are establishing, especially near the equator, which is on the Jupiter, Saturn, Uranus, Neptune. So yeah, I can.
Okay, I think this question is for Adam. One person asked, what are your thoughts about CERN successfully laser cooling antimatter?
You don't know.
You don't know. Okay.
About it. Sorry.
Okay. You don't know. Okay, not a problem.
It sounds possible. I guess it's tricky to do for long, but they do laser cooling to create things like Bose-Einstein condensates. So it should be possible as long as it doesn't hit any of the matter that makes up the device that the antimatter's in.
All right. Again, weird question. Is like, okay, what are your thoughts? Speak. Next question is for Christine. How successful do you anticipate Ingenuity will be? And what are the hopes for future Martian drones for research?
How successful? I mean, fingers crossed, I guess. I'm not an engineer, and I'm also not really a Mars person, so I'm not the best person to answer this. But, you know, I do think that the people who have been working on this technology have been working on it on Earth settings, at least, for a really, really, really long time. And they wouldn't bother. And this is true, I think, for everything they do at NASA. They wouldn't bother sending it if there wasn't a very good chance that it would work, at least in part. So I think the first flight will probably be a success. I think the real kind of gray area is it going to be able to actually last the full 30 Martian day period? Is it going to be able to heat itself? Things like that. So I would say first flight probably going to be good. The rest of them, we'll see. But it'll still be a learning experience either way.
Okay. Next question for you is Ingenuity similar to Dragonfly?
Yes, in some ways, and no, in other ways. So they're both helicopters. Ingenuity kind of just is like, at least as far as I can tell, again, not an engineer, along a single axis and has, I think, like 2 little helicopter things going on, whereas Dragonfly is built more like a quadcopter, so it's got like 4 different spindly things with different helicopter things rotating it around. And I think the main reason for that is because I told you Ingenuity is just a technology demonstration. It's literally just the tiniest little helicopter they could fit on there, just enough to get it to work. whereas Dragonfly is its own science mission. So it's carrying a lot of science instruments on it. It's going to be much bigger and heftier, and it needs that quadcopter capacity in order to move all that stuff around. And the other thing is that Titan has a much thicker atmosphere than Mars does. So the technology there in navigating a really thin atmosphere versus a thicker atmosphere is a little bit different as well. But they will both be helicopter missions.
All right, next question. I think this is another question for Sam. Any other info for us to help birds on migratory paths?
Ooh, yay. I love talking about wildlife and the connections with dark skies and wildlife, as many of these folks can attest to. I never shut up about it. So now you all get to listen to me too. So one of the really big things is providing native plants in your yards. That's a really, really helpful and beneficial thing to do, especially for birds like hummingbirds. Most people don't know this, but they migrate thousands of miles every year. These little teeny tiny birds that have to beat their wings like hundreds of times a minute. They're going from Canada to Mexico every year. And those little tiny bodies need lots and lots of food in order to survive that migration. So planting native plants in your yard is hugely beneficial. If you're able to put out bird feeders, that's also really beneficial. One big thing is feral cat populations. Those have devastating impacts on wild animals, especially wild birds. And so if you are able to volunteer to help trap wild cats to get them fixed so that they don't have more kittens, it's a really useful thing to do. If you can adopt them and keep them inside, even better. I'm guilty of not being the best about that. I have an indoor-outdoor cat, but she has a really big bell on her collar so that she is heard by every single bird that is in my yard. But yeah, so providing that food, providing that habitat, and helping with that citizen science project like eBird, that is really beneficial to help us see the migration patterns, because scientists can't be everywhere at once.
All right, next question. It's about Ingenuity again. Is there a plan to retrieve Ingenuity, or is it now a permanent fixture on Mars?
I think, like everything else we've put on Mars, it is now a permanent resident. That being said, maybe in the future, I mean, the whole idea with Perseverance, besides all the other good science is doing, is to prepare for a Mars sample return. So we're going to eventually send something there to take something back, and that's kind of step one in being able to get back and forth to Mars. So who knows? Maybe someday we'll have like the Martian thing, and we'll strand an astronaut there, and he's going to be like, it would really help if I could pick up Ingenuity and dust it off and communicate and tell them I'm still alive. You never know. It's possible. But in the near future, no.
I just picture basically some rover going up there, folding up Ingenuity again, packing it up and sending it back, and we put it in the Smithsonian. That's what I picture.
That'd be really cute too.
Next question. If any Perseverance was there any Perseverance wheel damage so far?
I don't think so. Yeah, I haven't heard anything about it unless they're keeping that a secret. But as far as I know, things are going to plan so far.
All right. Next question, and bouncing back to Sam. If tall buildings turn off their light, will this be a danger to birds flying into them?
That's a really great question, and an area of research that I don't have nearly as much knowledge about. The biggest thing is that we as a society, we feel more comfortable having lights on at night, where we've grown accustomed to having that. But it's not really necessary. And so reducing the lights that you have on outside, changing them to be motion sensor if you can, replacing blue leaning lights with red leaning lights that are less bright is really beneficial as well. That gives you the ability to see what you need to see at night without producing as much light pollution. Shielding those lights so the light is focused down onto the ground where you really need it versus letting it, again, go up into the atmosphere. As far as birds flying into large buildings at night when they turn off their lights, I would have to do a little bit more research on that. In my mind, they wouldn't have as many issues. And we do see very clear evidence that when those large buildings turn off their lights, the impacts reduce. there's a significant reduction in the amount of birds who are running into them. But I don't know the exact numbers. The links that I put in the chat, I believe they have links to some of the research that's done into that.
Okay. All right, folks, are there any more questions for these amazing panelists? Well, if there are no more questions, thank you folks all for joining us. And as always, cheers to the universe. Have an awesome night, and we shall see you sometime in April.
Thank you.